For centuries, Isaac Newton's laws of motion reigned supreme. The universe in this view was a giant clockwork mechanism. The future unfolded predictably from the past. Planets orbited stars, apples fell from trees, all governed by precise mathematical formulas. This deterministic view permeated our understanding of the world. It fostered a sense of order, a universe where cause and effect dictated every event. Enter quantum mechanics, a revolutionary theory that forever changed our understanding of the universe. Quantum mechanics revealed that at the subatomic level, the world is a fuzzy, uncertain place. Particles don't behave like tiny billiard balls. They exhibit wave-like properties existing in a superposition of states. Instead of definite positions and momentums, quantum particles are described by probabilities. The act of observation, the very attempt to measure a quantum system, forces it to choose a specific state. This is where the famous thought experiment of Schrödinger's cat comes in, illustrating the bizarre implications of quantum mechanics on a macroscopic level. In 1935, Austrian physicist Erwin Schrödinger devised a thought experiment to highlight the paradoxical nature of quantum superposition. Schrödinger was deeply intrigued by the strange and counterintuitive principles of quantum mechanics, which were being hotly debated at the time. Imagine a cat sealed inside a box with a diabolical contraption. This setup was not just any ordinary box, but a carefully designed experiment to challenge our understanding of reality. A tiny amount of radioactive material has a 50% chance of decaying within an hour. This radioactive substance is the key to the entire thought experiment, as its behavior is governed by the principles of quantum mechanics. If it decays, a mechanism triggers a hammer, smashing a vial of poison, killing the cat. The mechanism is designed to be precise and unforgiving, ensuring that the fate of the cat is directly tied to the quantum event. According to quantum mechanics, until the box is opened, the radioactive atom exists in a superposition, both decayed and undecayed. This superposition is a fundamental concept in quantum theory, where particles can exist in multiple states simultaneously. This means the cat is also in a superposition of states, both alive and dead, a concept that defies common sense. The idea that a macroscopic object like a cat could be in such a state was meant to illustrate the absurdity of applying quantum mechanics to everyday objects. Schrödinger used this thought experiment to criticize the Copenhagen interpretation of quantum mechanics, which was the prevailing theory at the time. The Copenhagen interpretation suggested that particles exist in all possible states until they are observed, which argued that the cat only collapses into a definite state upon observation. This means that the act of observation itself plays a crucial role in determining the state of the system, a notion that Schrödinger found deeply troubling and paradoxical. Schrödinger's cat has since become one of the most famous thought experiments in the history of science, sparking countless debates and discussions. It has been used to explore the nature of reality, the role of the observer, and the limits of human knowledge. Today, the thought experiment continues to inspire new generations of physicists and philosophers as they grapple with the mysteries of the quantum world. It serves as a powerful reminder of the strange and wondrous nature of the universe we inhabit. The concept of superposition is crucial to understanding quantum mechanics. It states that a quantum system can exist in multiple states simultaneously until a measurement is made. This is not to say that the system is simply in one state or the other, and we just don't know which one. It truly exists in a combination of all possible states at once. Think of a coin spinning in the air. Before it lands, it is neither heads nor tails, but in a superposition of both. Only when it lands and we observe it does it collapse into a definite state. Similarly, Schrödinger's cat is both alive and dead until we open the box and observe its state. The many worlds interpretation, or MWI for short, offers a radical solution to the measurement problem in quantum mechanics. Proposed by Hugh Everett III in 1957, MWI suggests that every quantum measurement causes the universe to split into multiple parallel universes, each representing a different outcome. In the case of Schrödinger's cat, instead of collapsing into one state or the other, the universe splits into one, where the cat is alive and another where it is dead. We, the observers, also split into two versions of ourselves, each experiencing a different outcome. MWI eliminates the need for wavefunction collapse and preserves the deterministic nature of quantum mechanics. Section 6. Infinite Use Exploring the Multiverse. Imagine standing in front of a mirror, but instead of just one reflection, you see countless versions of yourself, each slightly different. This is the essence of the multiverse theory. If the many worlds interpretation is correct, then an unimaginable number of parallel universes exist, constantly branching off with every quantum interaction. Each decision, no matter how small, creates a new universe where a different outcome occurs. This means there are infinite versions of you out there, each having made different choices and experienced different outcomes. In one universe you might be a renowned artist, while in another, you could be a scientist making groundbreaking discoveries. Some versions of you might be wildly successful, achieving dreams you never thought possible, while others might have taken paths that led to entirely different lives. The possibilities are endless and fascinating to contemplate. This concept, while mind-boggling, has profound implications. It suggests that every choice we make is significant, as it creates a new reality. It also raises questions about the nature of our existence and the true extent of our free will. It challenges our notions of identity, free will, and the nature of reality itself. Are we truly in control of our destinies, or are we just one of many versions of ourselves, each living out different possibilities? If every possible outcome of every event is realized in some parallel universe, does that mean our choices are ultimately meaningless? Or does it mean that every choice is meaningful, as it creates a new branch of reality? Or does it empower us, knowing that countless possibilities await us in the vast multiverse? Perhaps understanding the multiverse can inspire us to live our lives more fully, knowing that every decision we make contributes to the tapestry of infinite realities. The multiverse is not just a scientific theory, it's a profound reminder of the endless potential within each of us. Section 7. The Implications, Free Will and Destiny. The many worlds interpretation raises profound philosophical questions about free will and determinism. If every possible outcome of every decision exists in some parallel universe, does it mean our choices are predetermined? Or do we have the freedom to choose our own paths, even if those paths lead to different universes? Some argue that MWI supports a deterministic view of the universe, where our fates are sealed, and our choices are merely illusions. Others believe that MWI enhances free will, suggesting that we have the power to create our own realities, even if those realities exist in different universes. The debate continues to rage on, with no easy answers in sight. Section 8. Beyond Comprehension, the Limits of Our Minds. The many worlds interpretation pushes the boundaries of human comprehension. Our minds, evolved to navigate a classical world of cause and effect, struggle to grasp the implications of infinite parallel universes. The sheer scale and strangeness of the multiverse challenge our most fundamental assumptions about reality. Yet, despite its mind-bending nature, MWI offers a compelling and elegant explanation for the mysteries of quantum mechanics. It removes the observer-dependent nature of reality and preserves the underlying determinism of the universe. Whether or not we can ever truly comprehend the multiverse, it remains a tantalizing possibility, forever altering our perspective on our place in the cosmos. Section 9. The Search Continues, Unveiling the True Nature of Reality. The debate surrounding the many worlds interpretation, like many interpretations of quantum mechanics, remains unresolved. This interpretation suggests that all possible outcomes of quantum measurements are physically realized in some world or universe. It challenges our conventional understanding of reality, proposing a multiverse where every decision spawns a new universe. It is a testament to the profound and mysterious nature of the quantum realm, a realm where our classical intuitions break down, and reality itself seems to dissolve into a sea of possibilities. In this domain, particles can exist in multiple states at once, and their behavior can only be described probabilistically. This defies our everyday experiences and forces us to rethink the very fabric of existence. As we continue to probe the depths of the quantum world, we may one day find definitive proof for or against MWI. Researchers are developing increasingly sophisticated experiments and technologies, such as quantum computers and particle accelerators, to test these theories. Each discovery brings us closer to understanding the true nature of reality. Or perhaps a new, even more radical theory will emerge, challenging our understanding of reality in ways we cannot yet imagine. The history of science is filled with paradigm shifts from Newtonian mechanics to Einstein's relativity, and now to quantum mechanics. Who knows what the next revolution in physics will bring? The journey of scientific discovery is far from over, and the universe continues to surprise us with its beauty, complexity, and profound strangeness. As we gaze into the cosmos and delve into the quantum world, we are reminded of our place in the vast tapestry of existence. The quest to unveil the true nature of reality is a never-ending adventure, one that pushes the boundaries of human knowledge and imagination.